Hi everyone, this lesson will be a cumulative lesson on how to solve log and exponential equations. So don't forget, if it's logs, condense to a single log by using the properties such as the product, the quotient, and the power, okay? And then convert using inverse functions. So for example, if the function or the equation you're given a log equation, then you take the inverse by taking the base of the log, raising it to the power of y, and setting it equal to x. So that's what this means. And if you're going from exponential to logarithmic, then you do the same thing. Okay, so we've done this in class, and this is also in the previous notes packet. So once you've done this, then you solve the equation. So let me go over the first example. So in this case, we have it in this form, right? So notice this is the base of the log. So when I convert to logarithmic, I'm going to say this is the base of the log. So log base 3 of the number 12 is equal to what's in the power of the base. So I'm going to write down what I just said, log base 3 of the number 12. Notice that I'm using a parenthesis for this 12, and that equals 4x plus 1. But then I'm solving for x, so that's the next step. I'm going to subtract 1 from both sides of the equation. And be careful with this, because that 12 belongs to the log. So log base 3 of 12 inside of a parenthesis, and then I'm subtracting 1 outside. So notice, you cannot subtract 1 from 12, okay, because this is the log, right? So that's one expression, and this is minus 1. So you cannot combine these two the way they are right now. So then this is equal to 4x. Then since I'm solving for x, I'm going to divide by 4 on both sides of the equation. So then I'm going to enter this in a calculator, and I explained how to do this on the last lesson. So I'm going to press, let's see, I'm going to press the alpha key to get a fraction. And then here, I'm going to press alpha window and then 5. So the base of this log is 3. The number is 12. And then I'm going to scroll out, subtract 1, and then scroll down and enter a 4 in the denominator. So once I've done all of this, I press enter, and it gives me 0.315. So we're running to 2 decimal places. So this is 0.32. Okay, that's the approximate value of x. All right, the next example. So now notice we're going from logarithmic to exponential. So we're doing this. We take the base of the exponential of the logarithmic, we raise it to the power of y. So in this case, it's going to be negative 3 over 5. And we set it equal to x, which is the number 17. So then I'm going to take the base of this log, raise it to this power, and set it equal to 17. So this is what I just said. X to the negative 3/5 power is equal to the number 17. So then what I'm going to do is I'm going to multiply by the reciprocal power of negative 3 over 5, which is negative 5 over 3. So then this gives me the value of x. Okay, so then I'm going to go to the calculator and enter 17. And raise that to negative 5 over 3 as a power. And then press enter. Since I'm running to 2 decimal places, then x equals 0.01, because this is 0.008. So I'm running that 0 to a 1. So this is the solution to this equation. Okay. Now let's move on to example number 3. Notice we have 2 logs, but this one is on this side of the equation and this one's on the other side. So I'm going to subtract this log. I'm going to move it to this side. Since it's positive here, it's going to become negative on this side. So then this is log base 6 of x minus log base 2 of x is equal to 0. Okay, then I'm going to condense to a single log. So condensing to a single log, I'm going to use the quotient property. So log base 6 of x, this is a 2, right? I don't know why I wrote an x. So log base 6 of 2. So then the 2 goes in the denominator. So then this is equal to 0. But then I'm going to take the inverse of the log. So I'm going to take the base of the log, raise it to this power, and set it equal to x over 2. So this is what I just said. 6 to the 0 power equals x over 2. But 6 to the 0 power, or any number or variable to 0 power, is 1. So then this becomes 1 equals x over 2. Then I'm going to write a 1 and then cross multiply. So once we do that, this is 1 times x, which is equal to x, and 1 times 2, and that is equal to 2. So that means the solution to this equation is x equals 2. Okay. All right. So for the next example, I have the, this will be done with the calculator. Okay. So what I'm going to do is I'm just going to enter this information in the calculator. So let's see, I'm going to press the alpha key and then the window key and then the number 5. So notice the base of this log is 7 and the number is 6 over 5. So 6 in the numerator and 5 in the denominator, then press enter. And it gives me 0.0936. So this means that x is equal to 0.09. And again, we are rounding. Okay, don't forget that we're rounding. So this is not exact. All right, next example. So for this example here, let's see. So for this next example, we have a log, right? But notice that we are adding 2 logs, and this is one log and this is the other. This is plus, so that means we can apply the product property to this. So I'm going to condense to a single log. So log base 2 of x times x minus 2 is equal to 3. Then I'm going to expand or distribute this inside of this parentheses. Okay, so then this becomes log base 2 of x times x is x squared, and x times negative 2 is minus 2x, and this is equal to 3. Now I'm going to take the inverse of the log. So 2 to the 3rd power equals x squared minus 2x. So 2 cubed is equal to x squared minus 2x. But 2 cubed is 8. So 8 equals x squared minus 2x. Then I'm going to subtract the 8 from this side and also from here. So then this becomes 0. So I'm going to come over here for the sake of space. So then this is x squared minus 2x minus 8 equals 0. Now, this is a quadratic, so we're back to factoring. So we need to find the multiples of a is 1, c is negative 8. So multiples of negative 8, that when we add those multiples, they add to a b value of negative 2. So this is 2 times 4. But the 4 has to be minus, because 2 minus 4 is negative 4. 2 times negative 4 is negative 8. So then this is going to factor as x plus 2 times x minus 4. Now, don't forget, you can have x minus 4 first or x minus 2 first. That makes no difference. It's going to be the same thing. So then set each factor equal to 0. So that means x plus 2 equals 0. And the other is x minus 4 equals 0. For this one, we solve for x. We find that x equals negative 2 because we just subtract 2 from both sides. And for this one, add 4. So x equals 4. Also, don't forget with logs, we cannot have negative numbers. They are not in the domain. And also 0 is not in the domain of logs. So then this one, I'm going to cross it out. Okay, so this is the solution to this equation. All right, next example. So for this one here, this is a natural log, which means the base of this natural log is the number e. So take the base of this log, raise it to the power of 3, and set it equal to x plus 1. So e to the 3rd, which is a natural number, is equal to x plus 1. Then I'm going to subtract 1 from both sides of the equation. So then this side becomes e to the 3rd minus 1 is equal to x. Then I'm going to switch it up, and then I'm going to enter this in the calculator. So this is on the lesson from yesterday. Second, this is the number e. Okay, where you see the natural log, that's a number e. The power is 3, and then scroll to the right, subtract 1, and press enter. And it gives us 19.085. So I am going to round this up to 19.0, let's see, 9. So this is the solution to this equation. Okay, and again, don't forget, I'm going to keep saying this. This is an approximation, it's not precise. Last example. So for this one, we have an exponential equation. So then first I need to get the base by itself. I'm going to subtract that 3 from both sides of the equation. So then that gives me the base, which is a number e, to the power of x minus 4 equals 7 minus 3, which is 7. Then once this is isolated, I'm going to take the inverse of the exponential. Don't forget the base of this log is e. So then the inverse is going to be the natural log. So taking this base a natural log of this number, which is 7, is equal to x minus 4, which is the exponent in the exponential. So this is what I just said. Natural log of 7 is equal to x minus 4. And then I'm going to add 4 to both sides of the equation. And again, be careful with this. That 7 is out of a parentheses. So then this is ln, or natural log of 7, plus 4 is equal to x, which means x equals, then just enter this in the calculator. So this is the natural log key. And then 7 inside of the parentheses. Then let's add 4. So plus 4, and then press enter. And it gives us 5.945. So I'm going to round this to 5.95. And that is the approximate value for x for this equation. Okay, and that is all for this lesson. I'll see you in the classroom. Bye.